Hey everybody, this is Richard and welcome to another video by Making Something from Nothing. Today we're going to be doing a project on the lathe. I've got a customer requesting some components for a boring bar. Now it's not the kind of boring bar that we're used to. This is actually an Electrician, and they use these things to go underneath the sidewalks to run conduit. So he had an employee steal the only one that he had, so he's asked me to make 3 more, so this way he could put 1 on each truck. What we've got here is 303 stainless steel, and I'm going to break out a piece of paper and show you what we're going to be doing to it. Now I'm just going to make a chicken scratch drawing. It's going to be nothing perfect, but this is what the customer needs. This is component number 1. We're going to be making 3 of these. I've got a drill and tap for a 1/2-14 NPT thread, pipe thread, to accept something just like that. I basically need to turn this down to 3/4 of an inch, 3 inches long. Pretty simple, right? And the other side, we're going to go ahead and drill and tap that also for a 1/2-14 NPT thread. I have a taper attachment for my lathe. I've never used it. The gentleman I got my lathe from actually made it. It looks to be well made, but I am not sure if I could do a 15-degree taper, which is a 30-degree included angle, to make that spear point. I believe the taper attachment can do it, but I'm not really sure. It's probably pushing the limits on that thing, so I may or may not use it, but it would save me a lot of cranking on the compound. So we'll see what we can do. Let's go chuck one of these up, and we'll turn 3 inches of this down to 3/4 diameter, put a nice radius in the corner. And I can see right now it's going to be a fun day. Well, it seems to be cutting pretty good, so I think I'll go ahead and speed this up and take a little bit more of a cut. And it's breaking a really nice chip right here. Well, it looks like I kind of found the sweet spot on this 303 stainless. Getting some really nice chips off of this thing. Yeah, we're at 750 right on the nose, so I'm going to call that good. The radius tool leaves a really nice surface finish on the stainless, so I'm going to go ahead and use it to do the final pass on this shaft. Well, this is the third and final one, and I'm going to go ahead and flip these things around in the chuck, and we're going to start drilling them out to 1.5 inches deep. They all look relatively the same. Not that it really matters. They're going on 3 different trucks. There was really no specs on it, so, but as you can see, they're looking pretty sweet. So I'm still waiting on the drill to come in off the slow boat from eBay. It'll arrive next week. Today is Saturday. So there's nothing else I can do until I get the drill to go ahead and drill out to tap it for this. It's a new day, and just like all great plans, they change. And our plan has changed since I did the little introduction to this project. I'm not really sure what I said at the beginning of the video because it's been a couple of days. But basically, this part here that I just machined is this back piece. And this is going to be hammered on with some type of a pneumatic air gun. They're going to insert approximately a 3.5 foot bar in between the 2 pieces, and they're going to drive this underneath the sidewalk to go ahead and install some conduit underneath the sidewalk. That's what this tool is for. Now, the plan has changed a little bit because originally I was going to go ahead and drill this out to 45/64, which is the tap size for a 1/214 NPT tap. But the problem with that design is this. If I machine threads into these pieces, there's going to be a lot of force exerted on this by the pneumatic air gun. So they're going to be pushing on this thing, they're going to be pulling on this thing, you know, backing it out. And the problem with this design, for me to machine the threads directly into these stainless pieces, is if the threads get boogered up, well, the part is basically toast at that point. It's no good, it needs to be remade. So what we're going to do to get around that is, instead of machining the threads directly into the part, I'm going to bore this out to exactly 1 inch and 1.5 inches deep. And the customer had supplied me one of these guys to use as a test fit for, well, let me go ahead and show you. The customer had supplied this and one of these so I could go ahead and do a test fit on my threads, which was all fine and well. But what we're going to do instead is I'm going to go ahead and turn the outside of these down to exactly 1 inch. But what I'm going to do is I'm going to go ahead and bore this hole out 1 inch diameter, 1.5 inches deep. That's how long these are. I'm going to go ahead and machine the outside of this down to exactly 1 inch. Bore this out to 1 inch. We're going to insert this into that hole. We're going to Loctite it in place and then hold it with 2 set screws on either side. So if the threads get boogered up through use, the part doesn't become trashed, only the sleeve is. So we're going to go ahead and Loctite that in, use 2 set screws, and if the threaded portion ever needs to be replaced, all we need to do is take a heat gun, or not a heat gun, but a propane torch to it, heat it up, break the Loctite bond, pull out the set screws, pull one of these out, put a new one back in, and Bob's your uncle. So that's what we're going to do. So I'm going to go ahead and swing these on the lathe with this guy right here. This is about 15 to 20 thousandths over 1 inch. So we're just going to take a skim cut, get rid of this galvanizing, so the Loctite has nice steel to grab onto. So let's get on to that. Okay, I've got 10 thousandths dialed in on the cross slide, so we're going to take 20 thousandths off the diameter. Should leave us about 5 thousandths under 1 inch. And then I'm just going to go ahead and keep swapping out parts until I get all 6 of these done. I'll leave everything the same. I'll just go ahead and take the cut and move on to the next one. So we'll see how this looks on this first one. Hopefully we'll get a good surface finish, something for the Loctite to grab onto. Here we go. Okay, that's what we're looking for. Let's see what we got for a measurement. Should be about 995. And whatever that number is what we're going to make the other 5. So I'll go ahead and pull this one out, put another one in, rinse and repeat. So we got all 6 done. Surface finish turned out pretty good on it. Give something for the Loctite to grab onto instead of that galvanization. So now we'll go ahead and move on to these guys here and start enlarging this hole and bore it out to drop one of them in. Now let's see how we're going to chuck that. That should fit right into the spindle bore. Yeah, I like that. I've got a real good quality 1/2 inch drill here, coated, extremely sharp, should do good on that stainless. Let's see how it goes. Now I'm not sure what kind of result we're going to get with the boring bar on this stainless steel, so just for the heck of it I'm going to put the boring bar in right now. Go ahead and make a test cut while we still have the diameter small, and we'll see how it goes. About 10 thousandths or 20 thousandths off the inside diameter. We'll see how the boring bar does on the stainless. That's doing a superior job. Excellent. We'll go back to the 15/16 and drill that guy out. Well, that should pretty much put us right there. And there we go. Yeah, it's a nice fit. And I'll go ahead and Loctite that in and go ahead and face it off flush with the end of the part. Okay, we got a nice seat at the bottom for our little sleeve here. It's just a very light slip fit. Give us some room for some Loctite. But mainly it's just going to be going forward, so they're going to drive it going this way, which is going to force the sleeve further in, but it's sitting on a little shelf down there, so it's not going anywhere. It's just a much better design than threading the inside and ruining the part if you booger up the threads, in my opinion anyway. Now I used the radius tool that you see right here to go ahead and put in that radius, and I also used it to go ahead and turn down this side right here, and that's a great finish. So I'm going to go ahead and give all three pieces a little skim coat here and clean up the outside, because I never did machine the outside of this thing yet. So we're just going to go ahead and clean it up before I drill it and put a set screw in here.